All right. Hi, Year 11. This is Mr. Lim again, and this is another special request on how to work out from a shape, the polarity, and the types of van der Waals forces that it then has. Okay, so what are the 5 different types of shapes you can have for molecules? You can have linear, you can have V-shaped, you can have pyramidal, you can have tetrahedral, and you can have trigonal planar. And if you can't work out from an electron dot diagram what the shape is, you should go watch a video or ask about that later on. Okay, so just once you've worked out its shape, okay, you should be able to work out whether it's non-polar or polar. Now, the best way to do it is actually to look for non-polar variants because there aren't that actually many of them. So what do I mean by non-polar variants? Okay, so for the 5 different types of shapes, okay, you can only have non-polar variants if they fit within a specific type of arrangement of atoms, okay? Whereas, so if you're linear and you've got 2 of the same atoms, so something like Cl2, then they're going to be non-polar. All right, if you've got 1 atom that's different in the middle, and 2 atoms that are the same on either side, like CO2 will be, okay, like CO2, then that's also a non-polar variant. All right, and lastly, if you have all 3 in a row being the same, and O3 is a good example of that, then you're also going to be a non-polar. Anything else, any other variant, such as, like with 1 that is different and 1 that is 2 that are different, or 3 that are 2 of the same, 1 is different, or even 1 where they're all 3 are different, then they're going to be polar variants. Okay, so that's how you work out whether they are non-polar for linear. Okay, there are no non-polar variants for V-shaped or pyramidal. They're always polar. Tetrahedral, you're looking for 1 in the center, which is different, usually carbon, and 4 on the outside that are the same. Any other variation, such as maybe something like this, where it's 1 that is different from the other 3, that's going to be a polar molecule. If you have 2 that are different, that's going to be a polar molecule as well. And I don't care if you think that, there's 1 over here that will make it polar, that will make it non-polar. No, it's not, because remember, this is a 3-dimensional shape. So they're going to be they're going to be in plane with each other, and so therefore they're going to be a polar variant. And so only where 1 of them in the center is different and all 4 on the outsides are the same is that going to be a non-polar. Same with the trigonal planar. Okay, if you have 1 in the center that is different and then something else on the outside, that's going to be polar, and so therefore you don't have to think about that. All right, so these are the non-polar variants, as well as all hydrocarbons, no matter what shape they are and stuff like that. They're all going to be non-polar for all intents and purposes. So therefore, this is what you look for in terms of being able to identify if something is polar or non-polar. All right, then let's have a look at this. Okay, so once you've worked out whether something is going to be polar or non-polar, you can work out whether then they're going to have what types of van der Waals forces. So here are your van der Waals forces here. Okay, you've got dispersion, dipole, and H bonding, right? If it's non-polar, it's going to have dispersion forces only. Full stop, that's it. All right, and then the dispersion forces dependent on the size. If it's polar, it's going to have dispersion forces and it's going to have dipole, automatic, right? So they always have these 2 here. However, whether it has hydrogen bonding as well, it depends if there are 2 conditions that you need to fulfill. You need to have a hydrogen bonded to a nitrogen, oxygen, or fluorine. Remember, these are the very electronegative elements, okay? Just here, right? And you need to have an N, O, or F. They don't have to be on the same molecule, but generally when you're talking about melting and boiling points of pure substances, then yes, they are generally on the same molecule, but they can be on different molecules. All right, so that's how you tell, right? Polar, definitely going to have dispersion and dipole-dipole. But if it has these two conditions, then it's going to have hydrogen bonding as well. If it's nonpolar, it's only going to have dispersion. All right, that's it. Adios.